What's up, hipsters? Today, we're going to talk about solving equations with rational exponents. So, last time we talked about solving equations with radicals in them, and of course my pen doesn't work. We talked about solving stuff with radicals. Today, we're going to talk about how do we solve something if we have like x to the 3 halves power equals something. So this is not as bad, but it's going to take all of the skills you have learned in this unit and it's going to put them to the test. You're going to have to know how to do all of it. And you're starting to think, Mr. Barton, this is getting way too much. You know, I already don't understand the first two lessons. I already don't remember how to factor. I can barely add. My times tables are on shaky ground. My mom's yelling at me and the kitchen's dirty and I haven't taken the chicken out and I'm getting overwhelmed. And Mr. Barton, I don't... Breathe, kid. Breathe, all right? If you get overwhelmed, you've got a teacher who cares about you and is willing to sit through hours and hours of office hours to help you learn the material and go over problems with you. So far, no one's really asked me to do that, with maybe one or two exceptions. But if you need help, ask for help. Don't just sit there and cry about it. You know what I mean? That's what quitters do, and you guys aren't quitters. I can tell by the flavor of your voices. There are no quitters in this class, so make sure you ask for help if you need it. So let's go ahead and dive into solving equations with rational, that's code word for fractions, exponents. Write down these steps. There's 4 of them. I believe in you. You can write down 4 things. I'll even talk a little bit while you're writing. Go ahead, start writing. Number 1, isolate the rational exponent. So that means if you have like x to the 3 halves power plus 5 equals 1, you need to subtract the 5 and move it to the other side so that you have x to the 3 halves equals negative 4, right? You need to get the thing with the exponent by itself. After you have the thing with the exponent by itself, we're going to take a reciprocal of the exponent and do that new number as an exponent to both sides. So a reciprocal, if I have 3 over 2, the reciprocal of that would be 2 over 3. Okay, it just means take the fraction and flip it. Once we do that, stuff is going to cancel out left and right. Then we're going to solve for x. Just like last video, some of these solutions are not what they appear. There is an imposter among us, and we must check for imposters or extraneous solutions. All right, so we talked about the 4 steps. Let's go apply the 4 steps. Let's go try it out, right? Watching someone ride a bike and riding a bike are 2 very different things. So now that we've watched the video of Dave Mirra riding a bike, let's go try and ride a bike. All right. Example numero A. Numero A? Not quite, but... All right. So step 1 is isolate the rational exponential. So we need to get the base and the exponent alone. So we need to move this minus 5. So let's add 5 to both sides. These cancel. X to the 4/3 power equals 16. All right. The base and the exponent are isolated. Now we need to do a reciprocal exponent to both sides. So the reciprocal of 4 over 3 is 3 over 4. These cancel. And x equals, oh no, okay. So what does x equal? X equals 16 to the 3/4, but we need to simplify this. Luckily, you have a teacher who's already showed you what to do with fraction exponents. So recall, the bottom number is our index for the root, and the top number is the exponent. So let's rewrite this. X equals the 4th root of 16 cubed. All right, we need to simplify the 4th root of 16. If you have a calculator, it'll tell you. In fact, if you have a calculator, you could just type this in and it'll tell you the answer. But in case you're stranded on a desert island and a cannibal walks up to you and points a coconut to your head and says, solve this. Otherwise, I'm going to eat your eyeball. Never mind. We've got to do this by hand. So we factor the 16. 4 times 4. 2 times 2 times 2 times 2. Because our index is a 4, we're looking for a group of 4 matching numbers. So the fourth root of 16 is 2, and we still have that third power. 2 to the third power is ocho, or 8, for those of you who don't speak Italian. So x equals 8 is our answer. And now we have to plug it back in to make sure everything works. So we have 8 to the 4/3 power minus 5 equals 11. This I would just throw into your calculator. It's going to tell you that this is 16. 16 minus 5 do equal 11. So it works. Check mark, x does equal 8. Not too bad. All right, let's look at a slightly more complicated problem. And you're going to say, Mr. Barn, this is already complicated enough. Can't you lay off, homie? Can't you? Mr. Barn, it's Friday. It's Friday. It might not be Friday for everyone, kids. Remember, this is a recording. You could be listening to this on Saturday. In which case, you're ready to work because you didn't even have to go to school. So let's look at example B. We need to isolate the base and the exponent. That's this. So we need to get rid of this 7 and this 2. When we're solving, we're doing order of operation backwards. So we're going to get rid of the plus 7 first. So let's subtract 7. So we have 2 times x to the 3/4 power equals, what is that equal? 16. Now we have to divide both sides by 2. These cancel. So we have x to the 3/4 power equals 8. And now we have to do a reciprocal exponent. So the reciprocal of 3/4 is 4/3. 4/3. These cancel. And x equals, all right, let's rewrite this. Our root is a third root because the denominator is a 3. Put the 8 inside, put the 4 on the outside. The third root of 8 is 2 times 4, 2 times 2. Make a group of 3 numbers. X equals 2 to the 4th power, which is 16. So x equals 16. Now we have to plug it back in to this original problem. So we have 2 times 16 to the 3/4 power plus 7 equals 11. Let me just double check that I'm writing that. Oh, it doesn't equal 11. It equals 23. I'm getting my problems mixed up. Let's even erase that. Let's take care to make sure everything's clear. All right. So start by doing your exponent. Type that into your calculator. You're going to get 16 to the 3/4 power is 8 plus 7 equals 23. 2 times 8 is 16 plus 7 is 23. And 16 plus 7 is 23. So it works. So our answer is indeed x equals 16. All right, just a few more. Here, the base is x minus 1. The 2/3 power is on the whole thing because it's inside these parentheses. So what we need to do is start by getting rid of this exponent by doing a reciprocal. So we're going to do a 3/2 exponent on both sides. Here, it cancels, and x minus 1 equals 4 to the 3/2 power. We can rewrite this to simplify it. X minus 1 equals the square root of 4 to the 3rd power. X minus 1 equals, the square root of 4 is 2 to the 3rd power. X minus 1 equals 8, and then we add 1 to both sides. So x equals 9. Now we're going to plug it back in to make sure everything works out. So we have 9 minus 1 to the 2/3 power equals 4. 9 minus 1 is 8 to the 2/3 power equals 4. Rewriting this in a radical form, we have the cube root of 8 squared equals 4. The cube root of 8 is 2. 2 squared is 4. And 2 squared is 4. 4 equals 4. Check mark. That is the solution. So our solution is x equals 9. All right. Ooh, what a doozy. Do we have one more after that? A double doozy. All right. So let's go ahead and look at this problem. We need to isolate the thing the exponent is on. So we need to isolate this. All right. So let's start by subtracting 8. So we have 2 times 50x minus 1 to the 3/2 power equals 694 minus 8 is 686. Then we need to divide by 2 to get rid of the times 2 on our parentheses. So 2 cancels 2. And we have 50x minus 1 to the 3/2 power equals 343. Now we need to do our reciprocal exponent. So we're going to do a 2 over 3 power to both sides. So this cancels. 50x minus 1 equals, rewriting in radical form, the cube root of 343 squared. All right. Now the cube root of 343, we might need a calculator. If you don't know what goes into 343, start dividing. I happen to have an idea. I have a feeling it's 7. So let's try 7. It is 7. This number is actually 7 times 49. And then 49, we all know and love that as 7 times 7, right? So we have a group of 3 matching 7s here. So we can say 50x minus 1 equals 7 squared. And 7 squared is 49. So we have 50x minus 1 equals 49. We add 1. These cancel. 50x equals 50. Divide by 50. And x equals 1. Now, the dubious task of plugging it back in. So we have 2 times 50 times 1 minus 1 to the 3/2 power plus 8 equals 694. 50 times 1 is 50. 50 minus 1 is 49. So this parentheses simplifies to 49. The 3/2 power plus 8 equals 94. 49 to the 3/2 power is going to be, we plug it into a calculator, it's 343. 2 times 343 is 686 plus 8. 686 plus 8 is 694. And everything works out in the end. Check mark. So x equals 1 is our solution. Last example, and this is one of my favorites. So the base with the exponent is already isolated, so we can go ahead and do a reciprocal exponent to both sides. The reciprocal of 1 over 2 is 2 over 1. This is the same thing as 2. It's telling us to square both sides. So we're just squaring both sides to get rid of this square root that is hidden as a fraction. So we have negative 3x minus 5 equals x plus 3 squared. So we're going to write that twice. We're going to FOIL, and we get x squared plus 3x plus 3x plus 9. x squared plus 3x plus 3x plus 9. Combine like terms in the middle. So we have negative 3x minus 5 equals x squared plus 6x plus 9. Now, just like the last example in the last set of notes, we're going to move everything to one side. That's going over there. We have to do inverse operations. So we're going to add 5 and we're going to add 3x. So these cancel. 0 equals x squared plus 9x plus 14. And now we try and factor. So for 14, our factors are 1 and 14 and 2 and 7. To get 9, we're going to use 2 and 7. So this factors to x plus 2 and x plus 7. Now we set these factors individually equal to 0. So x plus 2 equals 0. X plus 7 equals 0. Subtract 2. X equals negative 2 is one of our proposed solutions. We're still going to have to check it though. And then x equals negative 7 is one of our other possible solutions. So we're thinking our solutions might be x equals negative 2 and x equals negative 7. But we need to plug these back in. We can't just blindly accept answers. We're not, never mind. I can't think of a way to make that not political. So apologies. All right, so plugging back in. Our equation is negative 3x minus 5, 1/2 power equals x plus 3. All right. I'm going to change the way this looks just to make it a little clearer what we're actually doing. A 1/2 power, the root number is a 2. And our exponent is a 1, so we're not going to write it. All right, let's plug in negative 2. So we have, let's do that one in blue. We have the square root of negative 3 times negative 2 minus 5 equals negative 2 plus 3. Negative 3 times negative 2 is 6, and 6 minus 5 is 1. Square root of 1 equals negative 2 plus 3 is 1. The square root of 1 is 1. So this one works. X equals negative 2. Now let's try our negative 7. Let's do it over here in red. So we're going to have the square root of negative 3 times negative 7 minus 5 equals negative 7 plus 3. On this side, we get negative 4. Over here, we have 21 minus 5. 21 minus 5 is 16. Square root of 16 is 4. 4 does not equal negative 4. So x equals negative 7 is extraneous, and we throw that away. So our answer is only x equals negative 2. All right. I did a little better on time on this one. I feel like I might have rushed a little, but again, if you're puzzled, perplexed, or you find this enigma insurmountable, go to the WebEx and say, Mr. Barton, you've presented an enigma to me. And then I'm going to say, watch your language. But I'll help you anyway. So if you need help, go in the WebEx, say, Mr. Barton, I need some help. Can you do some of my homework problems with me? And I would be happy to do that. Otherwise, don't forget to like and subscribe. Make sure you click the bell icon for notifications, and I'll see you guys in the next video.